the counting technique. Let's proceed. Well, we already did part of it. And so let's go to where we left off. The post increment operators. Right here. Okay. So as you can see, the in this last problem we just did, cell equal to cell plus 1. We had to write that. And so whenever you need to, I mean, in most of the programming with counting particularly, there's a variable that's going up by 1 always. So since this is so common, increasing a variable by 1, the C++ language offers an operator for that. So the operator is n++. So n++ means increment n by 1. So that is equivalent to writing n equal to n plus 1. But there's a minor difference between them. The n++ means increment n after using n in the current expression, because n may be, even if n is in the current expression, you can write the plus plus behind it to say that after using the n in this expression, increment the n. So when we do the examples, it'll be more clear. Similarly, n minus minus is used to say decrement n by 1. So you can write n minus minus as a statement. It is a statement and semicolon, but most commonly it's used within an expression. So n minus minus will be the same as by saying n equal to n minus 1, reduced by 1. But the convenience is when when you need to use when you need to say increment n by 1 or decrease n by 1, you have to write a separate statement. But if you're writing it as n++ or n minus minus, you can write it within the expression where it is being used. That's why it makes it sometimes convenient and makes the program shorter. So the operator is useful in that kind of situation. We'll be seeing that in examples. So let's go to the next page. So here's an example. This was the program we wrote to find the number that is closest to 200, but it's a power of 3. We wrote that in the section 4.1, and I'm rewriting it. Num starts at 3, and count is keeping track of the power. So here we need the power. So 3 is right now power 3 to the power 1. So that's why the count is 1. And while num is under 200, multiply num by 3 and increment the counter, so that counter will keep track of the power. So when you multiply num by 3, the power is going up by 1, so the count is going up by 1. So I'm repeating this. Only when the num goes, only when this is not true, loop will terminate. So when the loop terminates, num is over 200. At that point, count has the power of it. So I'm writing the count. So that's I'm determining the power to which 3 has to be raised to go over 200. That's what that count is. And if I use the count plus plus here, instead of count equal to count plus 1, then the program will become this. So the body of the loop changes. So count plus plus is a statement by itself with a semicolon behind it. So it didn't make much difference. The plus plus operator didn't change much, didn't make the program shorter or anything. But we'll see later. It'll be useful when you use the plus plus in an expression. So let's look at this example. M equal to m times k. That means I'm saying multiply m by k and put it back in m. Then change the k. The k is changing afterwards. So whenever I need to write those two lines, I could write this. That's where the plus plus operator becomes really useful. So this statement m equal to m times k plus plus means multiply m by the current value of k, then change k by 1. So Let me quickly do a simple example on the board. Suppose that the variable m is, this box represents variable m. And let's say I have 10 here. And then let's say I have k representing, this memory cell is what k represents. And let's say I have 5 here. Okay, then now m equal to m times k plus plus is executed. After executing that, what do we have in m and what do we have in k? Anybody?
15 in M and 6 in K.
It's m equal to m times k plus plus.
Oh,
Not,
sorry,
okay,
50
50 and
and 6.
6, that's right. So the k will increase only after multiplying the current value of k in this current expression. So 10 times 5 is executed. That'll make it 50. 50 goes into m. And after that, immediately after using the current value of k, k will change to 6. So the memory cell k changes to 6 right there. So if you print now, if you print the k afterward, it'll be 6.
Question.
Yeah.
So it's not 10 times
6. No.
K. No, it's not, right? Okay. Interesting. Okay.
Yeah, 10 times 5. The current, only current value will multiply and then the k will change. So that's a point you need to remember.
Mhm. So if you put that in a loop, it would go 50 and 6 and then 60 and 7.
Right, exactly. So it'll become useful in a loop. For example, if I need to say while something is true, while k less than or equal to 200, I want to multiply m by k, m less than or equal to 200. Then m equal to m times k, and then you would say k equal to k plus 1 in another line normally. Instead, now you can say m times k plus plus. So the body of the loop reduces size.
Can you say that it increases K for the next loop, right?
No, right after using the current value of k in this expression, k changes immediately afterwards. So in other words, that's equivalent to having while m less than or equal to 200, m curly bracket m equal to m times k, and then k equal to k plus 1. This is what that's equivalent to.
Okay.
All right, k changes right after that. So writing this is equivalent to writing this. Okay, moving on. So the plus plus operator written behind the variable means use current value in the current expression and then change the value of that variable. So if n has a plus plus or minus minus behind it, that means use current value of n in the current expression, then change the n. There's another operator coming up later that has completely opposite meaning. That's why I'm going step by step. So let's understand this first. Okay, so here's example. K equal to 3, m equal to 10, m equal to m times k plus plus, and then see out m and k. Okay, what will be printed by this?
Thirty and 4.
30 and 4 is correct. Very good. All right, so that's clear. I have already explained it, so I'm moving on. So look at this problem. We did this in the last class. This problem counts how many devices are there for the number entered by user. So here I'm asking the user to enter the number, I'm reading the number. And then my test number is the number I'm testing for divisor. Test num starts at 2, and while test num is less than num, if num modulus test num 0, that means if test number divides num evenly, then my counter goes up. So that way I'm counting all the devices of num. So right after testing test num, if it is divisor, count goes up, otherwise count doesn't go up. Either way, test number needs to go up. That's why test number equal to test num plus 1 is outside the if, it's not inside the if. So test number changes, and with the new test number, if test number is still less than num, then I'm testing that number. And if it is a divisor, counter goes up. Otherwise, counter doesn't go up. In either case, test number goes up to next. So this loop continues to test all the numbers from 2 to 1 less than the given number and counts how many devices are there. So, and then when the loop ends, I'm writing the answer here. Okay, that's the program we wrote in the last class to count the devices. Now, if I want to use the plus operator, see how the program will change. The test number needs to go up after testing this. After doing this test number needs to go up by 1, right? Whether this is equal to 0 is true or not, regardless of whether this condition is true or not, test number needs to go up. So I can put the plus right behind here, right behind the test num right there. That will change the test num. That will eliminate this line. That will eliminate this line. Okay, also the count equal to count plus 1 can be replaced with count plus. So if I change that to plus, then I don't need the curly brackets anymore. I only have one statement now in the loop. And both curly brackets go. So it shortens the program quite a bit. And it's a little more elegant with the plus operator. So that's why it's useful. It often simplifies matters and reduces the size of the program. So it is still the same. It works the same way as before. See, num modulus test num is tested, and right after testing test num goes up by 1. And if this condition is true, then the count goes up. Otherwise, count doesn't go up. But the test number has already gone up anyway. So with the new test number, you're checking this condition. If test number is still under num, then you're testing the new test number here. And the test number increases right after that. And so the program has shortened quite a bit. All right, so let's see see some more examples. Write a program to obtain positive integer number n from the user and compute the factorial of n. The factorial of n is written as n with the exclamation behind it in math. The meaning of that is multiply all the numbers from n down to 1. So 1, 2, 3, all the way up to n. This product is what factorial n is. So we need to write a program that will find factorial of any number entered by the user. So let's see if you can work it out on the board. We need to find factorial of number entered by the user. So I have to ask the user to enter the number first. I declare the variable as integer, and then factorial of the n has to go somewhere. So I'll declare that as fact. And initially, I'm going to store a 1 in it. And then, see, this factorial can be found by starting at 1 and multiplying 2, 3 all the way to n, or starting at n and going down to 1. So either way is correct. I need to ask the user to enter number and read that in n. And then to do the multiplication, I can write for loop for n going from 1 to n less than, I'm sorry, not n. N is our number, the number entered by the user. So I need a different variable, k. K going from 1 to k less than n, less than or equal to n, all the way to n, k plus plus, incrementing k each time. All I need to do is multiply fact by n, and the k, I'm sorry. The k is initially 1, so 1 times fact is initially 1 up here. So 1 times 1 goes back into fact. And then k changes after that, and then as long as k is less than n, less than or equal to n, fact is multiplied by another k. So I am multiplying by 1, 2, 3, all the way to n. All those numbers will be multiplying. So this will produce the fact. And when this loop ends, I can see out fact. Fact has the answer. Okay, so that's just one way. You can go the other way. You can go from n down to 1 instead of going from 1 to n. If you choose to put the plus plus behind the k here, fact times k, right there, I can put the plus plus. Then I'll eliminate the plus plus k plus plus inside. You can do that. You can have a semicolon and nothing behind it. That is allowed. And then k plus plus is down here. That's an option. So it can be written either way. So that's how you write the factorial. So here I have a version of the factorial program written here. Just repeatedly multiply. This one uses while loop. Doesn't matter, you can use for loop or while loop, but the for loop is clearly convenient since the loop control variable clearly goes from 1 to n. Okay, so warm-up exercise. This one says, write a program to obtain an integer number from the user and determine how many multiplications, 1, 2, 3, 4, these multiplications, how many of these have to be done for the number to go just over the given number. So if the user has entered like 981, then you need to determine how many multiplications here, 1, 2, 3, 4, all the way to wherever we need to. We don't know how far we need to go with that. How many of these multiplications need to be done to get the product to go over the given number 981, okay? So let me see if you can write that. You're counting how many of those multiplications are being done. So you need a counter. So I expect you to write it in the chat. You can also handwrite it and show it to me on your by putting against your camera.
I submitted in the chat.
Okay. All right, let me check the chat.
No, it's wrong. I can see it now.
Okay,
All right.
you can just re-enter the correct one.
That should do it.
New one. Okay. Let's see. Yeah, okay. 1 times.
I should have said count equal to 1. I can see that as well.
The count should start at 1, yes.
Yeah.
Start at 0, because at that point you don't have any multiplication done. So count started at 0. And yes, you got it. Very good. Anybody else? Only one student? Okay.
1 second, almost done.
Okay. Okay, in the meantime, I'm going to begin writing my version.
I submitted it in
Okay,
chat.
all right, let me check. Times campus plus. Right. Very good. Okay. So 2 students have them. Let me write my own. I declare int n, and then prod is where I'm going to keep the product of everything. So prod needs to start at 1, and the n is my multiplier, basically. That's why n is there. The multiplier is going to go from 1 to 2 to 3 and so on. I have to multiply by 2 and then 3 and then 4. So therefore the n will do that. So n needs to start at 2, actually, multiplier, because the product is already 1. So the very first number I need to multiply by will be 2. So that's why I'm starting at 2. But if you start at 1, that's not wrong. Just make sure you don't count that multiplication. And then I need a counter to keep track of the count of how many multiplications are going. So right now the count is 0 because I haven't done any multiplication. So the loop needs to say, I need to get the number from user. So cout, enter number. And I need a different variable for that because my n is multiplier. I'll call it num, declare it as num, and cin num. Okay, so num has the number. Now I need to keep multiplying by the multiplier. My multiplier is right now 2. I'm going to multiply prod by 2 by the multiplier and put it back in prod. That's how you multiply up many things. So I'm going to use while loop. Okay, the two students used for loop. That's fine. The for loop is not perfect for this situation because my control variable is not following a specific pattern here. So it's better to, well, at least for me, while loop makes more sense here. So while the prod is less than num. Say until prod goes over num, I have to keep multiplying. So while prod is under num, I need to continue the multiplication. So while prod is under num, I need to multiply prod by n. N is my multiplier. And it started at 2. And put it back in prod. And then n needs to go up, right? N must start at 2, and then after multiplying by 2, n should change to 3, getting ready for the next multiplication. So I put plus plus behind it. So now I'm multiplying prod by n and incrementing n right after that. In the meantime, I need to have another variable as counter. Now, by the way, the n itself can be used as a counter. I'll explain that later. But if you want to introduce another counter, you can do that. That's what I did, count equal to 0. Right now I have done one multiplication. Prod was 1 and n was 2. 1 times 2 has been done. And right there, my counter should go up by 1. So count plus plus. I'm using a separate counter, but n could be used as counter as well. Okay, I need bracket now because I have 2 statements. So this is it. That loop will continue to multiply by 2 and then 3 and then 4. As long as prod is under num, it'll keep going. And every time it multiplies by a new number, the counter goes up. So the counter is counting how many multiplications are being done. So when the loop is finished, the prod will be over num. Only when the prod goes over num, loop finishes. At that point, my count is the answer. So see out count. Okay, that's my answer. Now, let me explain now how you can use n as your counter. The n was 2 initially, and at that time count was 0. So right after multiplying by n changes to 3, from 2 to 3. When n is 3, we have done one multiplication. Then so you can see that the number of multiplication is 2 less than n. So then the n changes to 3, and the next time when the prod is less than m, if the prod is less than m, you'll be multiplying by 3, and then n changes to 4. So when you have done 2 multiplications, n is 4. So n is always 2 more than the count. So if I decide to use that as my counter, all I have to do is eliminate my counter, eliminate this, and see out n minus 2. N minus 2 is the correct count of how many multiplications have been done. You can see that n is 2 more than the count of the multiplications. So sometimes it is beneficial to use another variable that is already incrementing by 1 as your counter instead of introducing a new counter. It reduces the program size. See, if I do that, then I don't need the brackets here anymore. All I have is this statement inside the loop. This is the only statement in the loop. Okay, so let's move on.
One question.
Yeah.
Why is it n minus 2 and not n minus 1?
Because n is incrementing right after that, right? Right here.
Okay, I see.
See that? So it is, when the product is finished, immediately after that n is incrementing. So therefore, n is always 2 more than the number of multiplications, not 1 more. Got it?
Got it. Thanks.
I don't understand. Could you explain that one more time, please?
All right. Let me just write, trace them on the side. Prod is 1 initially, and I started my n at 2, right? I'm not using count anymore. N is 2. That's the initial value. And then I'm getting the number from user. So let's say a number from user is 900. Doesn't matter what that number is. But prod is 1 right now, so it is less than num. So I'm doing multiplication. This is my first multiplication. So when I do the first multiplication, I'm multiplying by 2, right? N is 2. But immediately after that, n changes to 3 because of n plus plus. So after the first multiplication, n has become 3. Prod is 2 now, n has changed to 3. I seeing that?
Yeah, I get it now.
All right. So I only did one multiplication, and the value of n is 3. Now let's do one more. Now I go back to the top of the loop, check the condition prod less than num. Prod is 2, num is 900, so it's still less than num. So I'm doing the second multiplication. Prod is now multiplied by 3, and that second multiplication, n becomes 4 right after that. So when n is 4, I have done 2 multiplications. Can you see that number of multiplication is 2 less than the n? Right?
Yes, yes.
Okay. And that's why I have to deduct 2 from n for the count. So if you think that is complicated, you can introduce the counter. It's no big deal. Introduce another variable for counter instead of getting too complicated. All right, moving on. The pre-increment and pre-decrement operators. Pre-increment, pre-decrement means plus plus and minus minus going in front of the n. So if it goes in front of the n, then it means increment first, then use it. So it will increment the variable first and then use it in the current expression. Same thing with the minus minus. You'll decrement first and then use it. So that makes a difference. It's completely opposite to the plus plus in the behind. Plus plus behind means use it and then increment. Plus plus in front means increment first and then use it. So let's see a quick example. Let's say M has a 10 and N has a 5. And if I say M equal to M times N, sorry, M times plus plus N. If I do that, then what will be M after executing this line and what will be N after executing that? Anybody?
Mm. 40 and
M-
4.
40, I'm not reducing anything.
50.
Oh, yeah, no, you're right.
And
It's a 60 and 6.
60 and 6 is correct, yes. So now N will be incremented to 6 first, and then that 6 will be used in this product, in this multiplication. So 6 will be multiplying the 10, and therefore you'll get 60, and the N is 6. Okay, so that's the difference. It appears to be minor difference, but it makes a difference. Unless you pay attention, you can get it wrong. So here, this is even if it is C out statement, in the C out statement also it will work the same way. Let me go to the board. If I write C out M or N plus plus, then what will be printed by C out? Let's say N has 6 right now. N has 6. So this will print what? 6 or 7?
6.
6, and then N will change to 7. So in any expression, including cout, if you have a variable with a plus plus behind it, then plus plus behind means use current variable in the current expression, which means it'll print out the 6 and then increment N to 7. So go to the screen now and look at this example. Num is 2, and then I have cout plus plus num, and then cout num plus plus, and then num. So there will be 3 numbers, one below the other. And can you tell me exactly what those numbers are?
Three, two, two.
Why are you decreasing? There's no minus minus anywhere.
Oh, I'm sorry. I meant wait. No, I mean 322.
Okay,
Isn't it 3, 2, 3?
3, 3, 4.
No, it's
Oh, I
it's
see.
3, 3,
Okay.
4. Yeah.
Okay, I see.
334 is correct. All right. Um, the first C out statement is going to increment num to 3 and then print. So that'll be a 3. Okay. Now, next one will print current value, which is 3, then increment to 4, increment num to 4. So there will be 2 3s now. The next one will be printing 4. Everybody's clear? So it'll
Yeah,
be
got it.
3 3 4.
Yeah, I was just I didn't change the value of num. Like after I did 3, I in my mind like num was still equal to 2. That's what
Right.
was my mistake.
That happens, yes. You need to pay attention to the details. All right, so let's go to the next question. So 334 is the answer. I already explained. If you don't follow that, please ask the question. I'll explain again. All right, next question is, if I write this program and run it, what will be the output? Three numbers.
14,
14, 5, 4.
5, 4.
Okay,
Yeah.
Alexander says 14, 5, 4. I think I heard Ivan, Ivan,
Yes, I said the same.
same thing, 14, 5.
No,
I will say
it's 13.
13. Oh, yeah, I will say 13,
13.
5, 4.
Yep,
Okay,
I got the same thing as Christopher.
very good. Yeah, that is correct. So 13, 5, 4 is correct because you'll be multiplying 2 by 6. I mean, it's 2 by 5 because k will be decreasing first and then multiplying. So 2 by 5, 2 times 5 is 10 plus 3, 13. N will change after that to 4. So it's 13 and then k will be 5 and then n will be 4. So 13, 5, 4. Okay, so I already explained that. Rewrite the program in example 5 using pre-increment. We don't need to do that. That's fine. Let's go on to understanding the order of precedence. Now, you know that the operators have order, and we learned that parentheses first, and then earlier we learned that multiplication, division, and modulus will be the next. But if there is plus plus or minus minus, that'll be next. Now that's clear because we already saw that before multiplication. Like if I have m equal to m times, we just went over that, m times plus plus n, then obviously plus plus n will increment the n. Only after that the multiplication will be done. So you already saw that. So the plus plus will be done before multiplication, division, or any of that. Only plus and minus will be the last one. So nothing more to memorize here because it's very clear. All right, so if you write expressions in your program using minus, minus, and plus, plus, you know, people can go crazy with it and write all kinds of expressions. And do they have meanings? Can the system handle them? Let's look at some examples. If I write k plus plus minus j like this, can the system understand that? Yes, there's an obvious meaning here. The minus should be the subtraction, and plus plus must be the incrementing operator for the k. So k will be incremented after doing the subtraction. Now it's be after doing the subtraction. So this will be understood. This can be done by the system. Okay, if I write this, is that going to work? K minus minus, then minus, j minus minus. That can be also understood because you have the parentheses. If the parentheses is missing, then it will be confusing because what is the meaning of writing K with the 3 minuses behind it? Let me write that on the board and explain quickly. If I write K minus 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 J, then it could mean K minus minus parentheses minus J. Also, it can mean K minus 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 J. So there are two meanings. Whenever there are two meanings, system will reject it. So compiler will reject it. So you have to use parentheses in that case. So if you write this, K minus 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 minus, so you may have meant to say K minus minus, two of the minuses should go behind K, two of the minuses should be in front of J, and then there's a subtraction. Maybe that's what you meant, but it's confusing because K minus minus and then another minus minus, that is allowed. It means reduce by 2, decrease K by 1, and by another 1. So that is allowed. So therefore, this can be now mixed up. It's confusing. It doesn't have one meaning, and that's why this will be error. So when there is no one meaning, it'll be error. So you can tell yourself, can I understand this? You know, is this, how is this, what is this expression? What does it mean? If you cannot understand it, if you cannot figure it out as to what it means, then same thing with the compiler. It will reject it. If you need, put parentheses like this, now it's clear. The minus in the middle is a subtraction. The others are decrement operators. So remember, it has to be clear as to what it means. Otherwise, it will be rejected. So these are, the other ones are all fine. This is the only one that is invalid here. It'll be error because it's unclear. All right, so moving on to warm-up exercise. If J is 3, K is 9, and what will be the values of both J and K and the expression? You know, 3 numbers you had to give me. Value of J, value of K, and the value of the expression given to you. Okay, start with the first one. Value of this expression will be?
-6.
-6. And J will be?
I would say -5.
No, -6.
J would be 4 and K is 9.
J will be 4, K will be 3. Let me explain why it's -6, because J, current value of J will be used here. So 3 minus 9 is what you're doing. Okay,
Yes, yes.
all right. So it will be -6 and 4 for the J and 9 for the K. All right. This one is clear, right? Minus, minus, and then plus, and then minus, minus. So this will not be rejected.
Question for A.
Yeah.
Why are you increasing it ahead of time? Isn't it before?
No, I'm not increasing ahead of time. I'm using current value of J, which is 3, right? 3 minus 9 is -6.
Right. Okay.
Okay. All right. Now we're doing this. This is accepted by the compiler because it does have a unique meaning.
11.
11. Okay. 3. No.
3 plus 8.
Yeah, I also got 11.
Right, you're right. 3 plus 8. Yes, you're right. 3 plus 8 is what we have, and that's 11. And after that, J will be 2, and K will be 8.
8.
Right. Okay. Next one.
36.
36.
Okay. 36, and J will be 4. K will be 8. Is correct. Anybody has any questions on these? Okay. Yeah. Everybody's good? All right, so 4.4 is your homework, and I wanted to do some of the 4.5. We can do a little bit, do whatever we can. Accumulation of sums and products. We just did one of those in the previous section. When you need to accumulate sum of many things or multiply some product of many things, you need to use this expression. Whatever the numbers you're going to add up should be added to sum. You need to start a variable called sum at 0, and then add the number, put it back in sum. You have to use the same variable sum. Only then you're accumulating sum of the numbers. Similarly, if you're multiplying, then multiply the start a product variable prod at 1 and multiply by the number, put it back in prod. If you repeatedly do that in a loop, then you're multiplying up many numbers. So I'm going to show you a simple example to begin with. So let's go to the next page. Next one. So suppose that I want to multiply all the odd integers from 1 to 30. Odd integers from 1 to 30. Now, to generate all the odd numbers, I can start at 1, and if I increment by 2, then they will be all odd numbers. So I start at 1 and increment by 2. So let's do that. I need to multiply up all of them. So what are the numbers I'm multiplying? It will be 1, 3, 5. So let me write them down. I'll have to multiply up 1, 3, 5, 7, all the way to 30. So to do that, what I will do is I will use a variable called k or n, some variable to keep track of that number. And then I'll introduce prod for the product of all these numbers. So int, they're all integers clearly. So int k equal to 1. Prod should also start at 1. I'm multiplying, so if you start prod at 0, then everything will be 0. So you have to start at 1. And then I can say while I'm going to multiply by the first value of k, which is 1 right now. Right after multiplying, I'll change k to 3. And then right after multiplying 3, I'll change to 5. So I'll keep going while k is under 30. So while k is less than or equal to 30, I say prod times k goes back in prod. I have to put it back in prod, only then I'm multiplying up. Now let's see on the side what happens to k and prod. K was 1, prod was 1. Right after this multiplication here, see, current value of prod is multiplied by k, and it'll go back in prod. So 1 times 1 goes into prod, and then k will have to increase right after that to 3. So k equal to k plus 3 goes right after that. Both of them have to be in the loop. So right after multiplying the current k, the k will change to, plus 2, sorry, plus 2. K will change to 3 now. So with the k equal to 3, I go back to the top, k less than 30 is true, so therefore I'm multiplying the current prod by k. Current prod is 1, I'm multiplying by 3, and so prod becomes, and that result goes back in prod. So prod now becomes 3, and after that, k increases to 5. And with that, we go back to the top of the loop, k less than 30 is true, so prod is multiplied by k. Prod is currently 3 and k is 5. 3 times 5 is 15. And then 5 changes to 7. Now you can see that the multiplication is going correctly, right? Multiplying by 3 and then 5. The result goes back in prod. It has to go back in prod, and only then you're multiplying up. So when k becomes 30, I'm multiplying by 30. And then the k changes to 32 and the loop stops. And the loop stops, multiplication by 30 has been done. So we just see out the prod, and that's our answer. Okay, so if I'm adding them up, it's the same thing. Only difference is while
Professor, we're at our time.
yes, I'm finished. So instead of multiplying, I'm adding up, then sum equal to sum plus num right here, this, and then num changes by 2. Num increments by 2. So it's the same thing if you're whether you're adding or, or multiplying. Now, a quick comment, instead of adding up num, the odd numbers, if I'm adding up reciprocals of the odd numbers, like 1/3, 1/5, 1/7, and so on, all I have to do is change num, change sum equal to sum plus num to say sum equal to sum plus 1/num, reciprocals. That's all there is. But then you have to make sure the division will be done correctly. So make it 1 point over num. Then you're adding up reciprocals of odd numbers now. All right, that's all I needed to do today. We'll continue from this in the next class. All right, your assignment is already up. It's due Monday. Due next Monday, and then next Wednesday will be the discussion class where I'll be taking questions from practice test. The review, it's called review 2. It's already posted on Blackboard. You should get started on those problems and bring up your questions for discussion. The following Monday will be the test. All right, okay. Enjoy the rest of the day. I'll see you Monday. Have a nice weekend too.
Thank you.
You
Professor.
take care,
You
Professor.
too.
Thank you. Have a nice day.
Bye now.
Have a nice day.
You too.
Professor, is the 19, correct?
What 19?
The 19 is the test?
I'm not sure it's 19th, but it's a Monday. I think it's the 17th. I'm not sure about the date. I can check quickly. Hold on.
Okay, but it's not this Monday. It's coming up the 12th.
Not this Monday. The following.
Okay. So, okay, thank you.